Hello everyone! Today we'll talk about the solution to the problem, the number of the smallest unoccupied chair. When we read the statement to this problem, we can quickly come to the conclusion that this is primarily a data structure based problem, and specifically we want a data structure that can maintain the set of available chairs, give us the smallest available chair, and since there is some freeing mechanism, then we have to be able to return chairs to the pool. And of course, some simple data structure based on an array or even on a linked list might have difficulties with the fact that by returning chairs to the pool, we might suddenly return a chair with a small number or a medium number, and we cannot maintain any data structure that will cause us to go through occupied chairs. We have to be able to, in a way, skip around and only look at unoccupied chairs. But really, we don't have to traverse the data structure too much because we only want to return the smallest chair. So we can either use a priority queue, a heap, and this is the data structure that it's the best to use here because it's faster than a binary search tree. And it's essentially exactly the feature set that we want. Or we can use a binary search tree. The binary search tree allows us to return chairs as we want. It also would allow us to get any type of chair, maybe the biggest, the smallest, to verify if some chair exists. Those are things that a heap will not allow us to do, but we don't need it in this problem. By the way, we have an infinite number of chairs, so that might seem like a problem, but it really isn't. We can model the infinite number of chairs as just before we use a chair, we just remember that, well, this chair was not used, so we remember the ID, the number of the last used chair, of the highest number used chair. So we start with that at 0, and whenever we want to get a chair but our free chairs are empty, we just insert this ID and increment it by 1. So all the infinite chairs are just here in this next ID variable. So we know that we're going to want a priority queue. And how do we solve this problem having a priority queue? Well, we are interested about a single friend, so we have to remember when that friend comes into the office. So this is just the times of that target friend and his arrival time. This is our cutoff. We have to maintain our free chairs, and this will be a simple priority queue with just the number of the chair. And we can get the smallest chair at any point and insert chairs back into the queue. But there is also this issue of things happening, people coming in, people leaving, and when a person comes in, we have to query our free chairs heap to give him the next chair. But we also have to make sure that when that person leaves in the future, we return that exact chair to the pool. So we can either remember for every person what chair that person was assigned to, so hold another array of the size the same as times, and that is a good solution. Or we might keep it in a single priority queue. Also, we want to go through all the events that we have. So we want to go through all the arrivals, but also all the times when people leave. The times that people leave should be processed before times when people arrived, if those times are equal. And we can do it either by sorting, and if you maintain the number of a chair for a given person in a separate array, then you can use sorting. Sorting is probably a bit better than using a heap. Or we can just use a heap. And if we use a heap, we can, at the beginning, only keep that heap sorted based on the arrival times. So essentially, we just take our times, we convert all the values to tuples, because tuples are able to be compared and lists are not really able to be compared. So we convert everything in our times to tuples, and we create a heap from it, which we should do by using the heapify method, because that method should run in linear time. Whereas inserting n items into a heap will give us an n log n running time. And now we'll be going through all our events. This is very typical in problems with priority queues. And now, when we have this event, we use the heap pop to get the event with the smallest value. So essentially the smallest time. And this I will be taking that I to be non-positive if it's supposed to be processed first, because smaller numbers will be processed first, to mean that this is a event of a person leaving, and now this value I, this non-positive value, is the negative of the number of chair that we want to free up. And in that case, we can push to our heap, our free chairs heap, the number of that chair. So this number will be kept negated, so we have to negate it here to push it back. And that's all that we have to do if we're now processing a person leaving. Otherwise, we're processing a person coming in. Now, if there are no free chairs available, as I mentioned, we have to create a new chair. You'll notice here that I write free chairs.append. What line should it be? Because this seems like a mistake, and maybe it is a mistake. Well, that line should of course be heapq.heap push free chairs next ID. And what do you think? Is this an accident that it works like this? Is it something that you should do? Because you probably shouldn't do it if it's not something that you can. It's probably not something you can rely on working. But if you're familiar with how a heap is implemented, you might also have an idea about why this works. And the hint is, of course, to look at how big this value next ID is compared to anything that can already exist within free chairs. So that's something for you to think about. But anyways, we add this next chair to our free chairs, and now free chairs are not empty. And now we take the smallest available chair. If we're at the cutoff point, so at the point where target friend arrives, we just return that chair number. Otherwise, okay, this person has taken this chair. We have to remember to give it back. So we push to our times heap the second value here, so this is the time that the person leaves, and the number of the chair that we've just given that person. Of course, negated because we want the events of leaving to happen before the events of coming in. And how would you change it if people leaving were to be processed after people coming in? Because here we're specified the order. Well, of course, it would be best to not negate the number of a chair, but to negate the time of leaving.